Greetings, everyone. My name is John Ruffin, and today I'm going to show you modern DevOps practices using all these things you see on the screen, with heavy emphasis on the Amazon Web Services Cloud Development Kit. Let me give you a little history. In the beginning, CloudFormation was Amazon Web Services' initial infrastructure as code. Anything you wanted to build in the Amazon Web Services, you could build with CloudFormation. This infrastructure as code paradigm, it gave you many gains over manually clicking, pointing in the AWS console and trying to create something there. Now, CloudFormation did come with some drawbacks. One drawback was that you had to be able to search the docs and understand every aspect of an element that you were trying to create. That's not necessarily a bad thing, but it's a little bit overkill. So your Amazon Web Services CloudFormation templates became rather long for even just the smallest of resources that you want to create. Along came a company called HashiCorp, and they created a tool called Terraform. Now, Terraform created the same AWS resources with fewer lines of code. And with Terraform, you can create resources for multiple clouds. So think Amazon Web Services, Google Cloud, and Azure. Many people jumped from CloudFormation over to Terraform. Then AWS came up with the Cloud Development Kit, which is an abstraction over CloudFormation. The Cloud Development Kit for AWS is so sweet that even Terraform borrowed most of the technology and created their own version of the Cloud Development Kit for Terraform. In general, a CDK is built on the concept of construct. These small constructs encapsulate everything that a CloudFormation template would need in order to create said resources. The constructs come with sensible defaults. Using a CDK is much simpler than using CloudFormation and or HashiCorp Terraform HCL. The CDK works by, and here's a key word, synthesizing. It synthesizes the constructs down to low-level CloudFormation for you, saving you a tremendous amount of time. Did I mention, in using the CDK, you get to use a modern programming language like Java, or Go, or TypeScript. This is a super huge boon to productivity in application development. You get to lean on decades of application development best practices. Think pragmatic programming. Think pragmatic unit testing. Think 12-factor apps, all built into your applications and now into your infrastructure. And in using a modern programming language, we can now use a modern integrated development environment like Visual Studio Code. Of course, it comes with code completion, debugging, and everything else that developers are normally used to when creating applications. Enough history and enough why. Let's start creating some resources. In initialization, this first section, we're going to talk about the CLI that comes with the Cloud Development Kit, the toolkit. And in Visual Studio Code, we're going to create a brand spanking new project using the CLI. Let's get started. I have Node.js installed, I have the AWS CLI installed, and I have the Cloud Development Kit toolkit CLI installed. As with any good command line interface, you should have some help. So I'm going to type CDK, that's H, that's for help, and we should get some good information. Now, if you saw that very quickly, we saw some red that flashed on the screen. I'm going to try today to force some hiccups just so you can see how I handle the hiccups. This is one hiccup that you might encounter. It says Node.js has reached end of life 2023, yada, yada, yada. Basically, it's saying that I'm using a non-supported version of Node.js. So how would I fix this? For me, I use Node Version Manager, NVM. I'm going to do ls. It's going to list the versions of Node that I have on the machine. And it says that I'm on a system. I really want to run this version right here, version 18.16.1. I'm just going to copy that. I'm going to tell Node Version Manager to use this version of Node because the warning is saying I'm using the wrong version of Node. Let's tell Node Version Manager to use that. Okay, we will now clear the screen. That would be CLI, clear, and we'll run it again. CDK-H, and hopefully that red should be gone now. All right, it did go by fairly quickly, and you can see that that red is now gone. But here's where I ran the clear, did the help again. Now, if you look at the commands, these are the commands that you can run with the CDK. Let's go through a couple of them, maybe in a little bit of order. So CDK lists. The Cloud Development Kit can list the stacks for you. Now, what is a stack? A stack is a collection of resources that you want to kind of work and create as a unit. So you may want to group networking resources together. You may want to group API resources together. You may want to group database resources together. So they come up, build up, come down all together in a stack. That's what a stack is. The synthesize command, this does what we talked about before. It transpiles the CDK code into CloudFormation. So the few constructs that we're going to use today in the CDK, you're going to see they're only a couple lines long, but then we're going to look at the CloudFormation that we synthesized down to, and that CloudFormation is going to be very expansive. So you'll see how much time using the CDK helps us over doing kind of raw CloudFormation. The next one is Bootstrap. Bootstrap is a command that you run in order to configure your remote AWS cloud environment. So the CDK, in order to run properly, it needs some things, some S3 buckets and some policies. So Bootstrap creates that in your AWS environment. CDK deploy, you can run CDK deploy to deploy one stack or many stacks. So that's why you have the array here of stacks, because it can be one to many that you deploy. Let's keep going. CDK watch is a really good command that you can use when you're developing. If you do -- watch, it's kind of like a hot swap. So it'll only do a full deploy if it needs to. If you're changing a resource that only needs, say, a small configuration change, everything in the stack that needs to change, then watch and hot swap will do that for you. But watch will definitely do it for you, and it'll do it automatically for you. So there's no manual intervention for you. As soon as you save it, it's watching your files. It's like, oh, this guy made a change. Let's see if we can deploy it. Destroy is just what you would think it is. It destroys or tears down the stacks. Diff is what you run to see what's different on your machine versus what is in production. This is a really good and kind of healthy command that gives you kind of like a sanity check that you're not about to do something stupid. Let's keep going. Init is what we're going to run in just a few seconds. This is going to create the new project for us in Visual Studio Code. We're going to close this terminal, open another terminal in Visual Studio, and run init. Matter of fact, let's just do that. So let's clear the screen. I have to type today. And let's make a directory. Make a directory called CDK50. And we will CD into CDK50. It's the 50th anniversary of hip hop. A lot of stuff going on, so I'm feeling the vibe right now. So,
hey yo, God, put the foundation on. Yo, Rick, I want somebody to buy the nigga shoe home. My God, Kobe shoes up and turn my cold. 6'1", 6'1", 6'1".
created a new directory, and then we told Visual Studio Code to open in said directory, CDK50, again for 50th anniversary of hip hop. And you can see in the terminal here inside of Visual Studio Code, I have already kind of preceded a command, and it is the CDK init. CDK init is going to initialize what? It's going to initialize a sample application for us. And what kind of application is it? It's going to use a template for TypeScript. So let's run this template, run this command, and see what it generates for us. Aha, did you see that red again? We're gonna have to fix that red again because we fixed it in the terminal, but not inside of the Visual Studio Code terminal. But let's look at the code very quickly. Let's see what it generates for us. So there's a TypeScript config. It's going to go from the bottom up. This ES20 target is somewhat important because if you don't do that, then TypeScript gets a little confused on how to transpile things. You got a basic README, you got a package JSON here, all standard stuff. You got a Jest config here, all standard stuff that tells it where to find and what type of files to look for in order to test. Now the CDK JSON, this is a very important file when it relates to the CDK. This gives it a lot of information, and really on line number 2 you see up there, that's how the application actually gets initialized and starts. So that line is pretty important. As you can see, it uses TS Node. We'll talk a little bit more about that in this screencast. That's very important to the library. And it's going to execute it from this location. So all this was created for us. All the handshaking should be working. What else is important? We've got a test directory. We're going to put our Jest unit tests in there. You can see here that it kind of already comes with a kind of preceded test. You got a lib directory. This is where your stacks live. So you can see here that the CDK and the template has created a temporary simple stack for us. What's important about creating a stack and using the constructs? When you talk about a construct, they all have a constructor, and the constructor has the same contract, so to speak. It all requires the same parameters. So it requires a scope. We usually pass in this because constructs are made in the context of other constructs. So you can think of it as a subconstruct. So scope is typically this. The ID, when you are instantiating one of these classes, is any string that you want to use for a name. And then props, this is where you would configure said construct. If a CloudFormation template has, 15 different options that you can set, inside of props is where you would set those properties, those attributes, those parameters. You set those in props. So you're going to see that. But
Here we go. We're about to run a time. Not long ago when people were pajamas left. Love was stirred and justice stood. People were behaving like a cartoon. There was been a boy who was misled by another little boy, and this is what he said. Maybe you know we're gonna make some plans. Robbing all rules and making a dash. Did your job, money gave a reason. What could have stopped like had a disease? Dropped up, trying to rubber man was a teacher to cover.
welcome everyone to section 2 of Dev plus Ops, where we're putting heavy emphasis on the Amazon Web Services Cloud Development Kit. Now, section 2 is all about Git and version control. If you know anything about 12-factor apps, this is an important component of a 12-factor app. What we're going to do, we're going to create a GitHub repo, and then we're going to add that repo as a remote for our local. And then we're going to do something fun because we're doing CI/CD in this screencast, and the CDK needs to be able to check out code from GitHub. So we're going to establish that handshaking in this section, section 2. Let's get started. So we have our app generated from the CDK TypeScript template. You may have noticed that it initialized a local Git repository for us. Local meaning on this laptop proper. We do not have a remote GitHub repo yet, and that's what we're going to do now using the Github CLI. I have the Github CLI installed. I'm going to use the Github CLI to create a repo for our CDK 50 project. GitHub repo, create. We're going to call it CDK 50 again for the 50th anniversary of hip hop. And I'm going to create a private repo, private remote GitHub repo. Let's see, enter. So now you can see it says it created that repo for me on GitHub. Now you don't have to go to the website anymore to create a repo. You can do it with the GitHub command line, and that's what we just showed you there. All right, so we have created our repo using the GitHub command line. Now we want to do a git remote We created a remote using the command line. Now we just connected this piece of code to that remote. Now we should be able to do a git push. All right, now we have successfully pushed from our local repo to our remote. The next thing that we have to do that is Git and GitHub related is to create a connection from AWS and the CDK over to GitHub. Those two need to have a handshake so they can transfer data back and forth to each other. Our pipeline is going to need this connection, and you're going to see us use it multiple times. So I'm going to create here in TypeScript, I'm going to create a constant. I'm going to call it gh connection. And it is going to be a new CFN connection. And you can see that we have multiple CFN connection classes here. We don't want the one from AWS events. We want the one from AWS code start connection. So we're going to import that from AWS code start connection. And again, everything that we're doing in the CDK is a construct. All the constructs have a similar contract, so to speak. So you can see here that the first parameter that we need to pass in is the scope. We're going to pass in this, as we pretty much normally do. I'm going to give it a connection name. That's arbitrary. It doesn't really matter what you name it, but just name it something that means something to you. And then again, in this next section, this is where we enter the parameters that this connection requires. One of the things that it requires basically is a connection name. You see down here at the bottom that that's already pre-filled for us. Connection name. I guess we can name it the same as this. Copy that. Again, this is arbitrary as well. And then the next thing we're going to need is a provider type. Provider type. So you can have a connection from GitHub, GitLab, and a couple other providers. So we're going to use the provider type GitHub. All right. So we talked about the AWS CDK and some of the commands. One of the commands is synth. In synth, what it does is it synthesizes the constructs down to CloudFormation. So this CFN connection that you're looking at now on line number 10, that is going to synthesize down to a fully exploded type of CloudFormation. Let's do a CDK synth. Now you can see the CloudFormation that it created. So after this command, this is the CloudFormation that's generated from those 3 to 5 lines of code. All of this is what we used to have to type, so to speak, in order to make a connection. So we no longer have to type all this. The construct does it for us. Now this is in the standard out where we're seeing the output of the synthesized code. This is not executing anything for us. It is doing a sanity check, almost like a dry run, making sure we're not doing anything that we don't want to do, give you an opportunity to look at it. And if you look over here to the right in the cdk.out folder, this is really where you want to come and take a look at this code. So again, this is the template that's created for CloudFormation. It's going to execute for us. The next thing we're going to do, CDK specific, is we're going to do a deploy. So we're actually going to run this code. Let's do it clear. We're going to do CDK deploy. Now CDK deploy also does a CDK synth before it deploys to AWS. Let's do a CDK deploy, and we only have one stack right now, so we don't need to give it the stack names. We're just going to run CDK deploy, and then we'll look in AWS and see what we have to do next for our connection
handshaking between our AWS account and CDK and our GitHub account. Run CDK deploy. This is going to deploy to AWS. There we have an ARN. And next we'll go over and take a look at it. I'm in my AWS account, and basically I went to CloudStar or Cloud Pipeline, and under settings over here, you will see connections. Click on connections and you'll see a connection. What's important here is you'll see I have an existing connection here, and then it says it's available, which means there is already handshaking between the AWS account and GitHub for that specific connection. This is the connection that we just created using the AWS CDK, and its status is pending. It's pending because we have not established the handshaking and the multi-factor authentication that GitHub requires for authentication. So in order to do that, we'll click on this name, and we will then click on Update Pending Connection. This is going to open up GitHub. So the next thing we want to do is click on Install an App. Now, if you have done this before, you would just go here and click in here, and your existing connection from your AWS account over to GitHub will show up. But let's just act like we haven't done it before. We'll install a new app, and I'll just walk you through the process. That brings up the connector in your GitHub account. What we're going to do is we're going to scroll down. We're not going to give access to all our repositories in Git. We're only going to give it access to select repositories in Git. And you can see there's already one repository that connector has authority to access. So we're just going to go here, give it access to that. We'll click Save. Now we're back in AWS land. This is the ID of it. We'll click Connect. I'm going to go back to the connector. Now you'll see that it's available. So now this connection is available for us to use in our applications, in our pipelines, to connect our AWS account to our GitHub account. So our pipeline is going to use this connection to grab code from
Welcome everyone to section 3 of Dev plus Ops, with heavy emphasis on the Amazon Web Services Cloud Development Kit. Hope you enjoyed section number 2, where we created a Git repo with the Github CLI. We didn't go to the website to create a GitHub repo, and then we attached our repo to the local, and then you saw how we used the CDK to connect to GitHub. And in CI/CD, we're going to have to grab that code from GitHub and run it through our pipeline, and the CDK connection to GitHub is what's going to enable that. In our code in section number 3, we're going to create infrastructure code and application code. I hope you know that Lambda is a compute service. A lot of people put a lot of focus on a Lambda function, but Lambda is a compute service, and with observability, performance, scalability, all those abilities that you're used to as an architect. Well, I have been as an architect. But yeah, it's compute. So that's how I think of it. Let's get started.
So being test-driven developers, we're going to create a services folder for our source and a services folder for our tests. We're going to call it RockM Lambda. So you can see how those correlate. I'm going to go through and type in the Lambda function fairly quickly. So a Lambda function takes an event in the context. Again, this is all in TypeScript. We're going to return something very simple, status code 200, and the body, again, from my favorite rapper, Rakim. How can I move the crowd? And then we have to export this handler to gain access to it. The next thing we're going to do, we're going to go ahead and create our tests. We're going to execute and exercise our code as good developers do. So there is a typical structure to writing unit tests. And here the structure that I like to use, I like to
write down how I want to arrange or set up some variables. I want to take some action. Then I want to assert, right? Write the asserts afterward. This makes it really clear what's going on. So we don't want to take the happy path on all of our tests. So let's change that to a 400. Now we're going to run npm test, and we're going to see that this test is going to fail. There are two tests, one that comes with the template itself and the other one that I wrote. The one that I wrote, I wanted it to fail. We expected it to be 200. We received a 400. Now we want to go in and fix it. Run the test again. Now everything should pass. Sound app dev.
Bring on the molten hold, don't snooze the dough, cause I'm ripping up shows. Hold your nose, dead bodies are around. I leave scratch marks under the tears of a clown. I write rhymes that shine like lipstick. So much material, but not materialistic. Imperial styles are used when the mic gets lifted. The crowd is amused. Make some noise.
Welcome back, everyone, to section 4 of Dev plus Ops, with heavy emphasis on the Amazon Web Services Cloud Development Kit. Now, section 3 and 4 are all about continuous integration, continuous deployment. In section 3, we created some code for our infrastructure, and we created some code for our app. In section 4, we're going to create the infrastructure that is going to run our CI/CD pipeline. In the CI/CD pipeline, we're going to create some stages, and those stages are going to contain the stacks. And the stacks we talked about are kind of logical groups of resources that we want to create as a group in AWS. So let's get started. To recap, in section 3, we created our Lambda function. We created a Jest unit test to exercise the function, and then we created a stack for the Lambda compute environment, which is where the Lambda function is going to execute inside of AWS. Now, we have not pushed anything to AWS. This is all on our local machine. We're going to push our pipeline, and then you will see on subsequent commits to GitHub, the pipeline is going to fire and update our Lambda function in resources for us. Let's get started with CI/CD. On line 21 is where we start to define the pipeline in code. We create a constant called myPipeline. That is arbitrary, of course. And it is going to be of type CodePipeline. It's going to be a new code pipeline. And because this is a construct, it has the same contract or same parameters required as most other constructs. So it needs a context. We're passing in this. It needs an ID. That ID is going to be a string. We're calling it Rakim pipeline again. Next, we have the parameters for the code pipeline. And these are the parameters that are going to override what we used to populate in CloudFormation. So we have a pipeline name, and this pipeline name is show improve pipeline. If you look over to the right, after we run this pipeline, there's going to be a code pipeline so to speak, in the browser. So we're going to create this pipeline from this code. It's going to be called show improve pipeline, and you're going to see that in the browser next. The next thing on line number 23, this is a synth step, so to speak, a shell step, and basically it's checking out code. And you can see that we're saying that the code pipeline source is what? Is the CDK 50 repo in GitHub. How do we connect to the CDK 50 main branch in GitHub? Well, we connect to it through the connection that we created earlier, the GH connection, and using the attribute connection ARN. So what do you do what do we do? What does the pipeline do after it checks out the code? Well, you can see that it runs on line number 27, npm clean install, and then it's going to run npx CDK sent. So we have a pipeline stage, and the stage needs to execute stacks. So we got stage and stack. So how do we connect the stage to the pipeline so the pipeline can know about the stage? Well, on line 31 is where we connect my pipeline, and we do add stage, and we add the Rockham pipeline stage. So now we're going to commit it to our local Git repo. And then we're going to push to GitHub. So we got the code deployed to GitHub. Now we're going to do a CDK deploy. This is going to push and create the resources in Amazon Web Services. You can see that it's creating a lot of roles and policies, and then it's gonna, after we say yes to that, it's gonna go ahead and create those resources in Amazon Web Services, all from code. Beautiful. In the code, we've created our pipeline, we've created our stage. The stage runs the stacks. Now what we also want to do is we want to run our tests in the pipeline. So before this stage executes, and if these tests do not pass, we're not going to deploy anything. So this is where the CI/CD, the testing part of CI/CD comes in. Now let's look at some of the resources the CDK has created for us. Let's look at our pipeline. This is the pipeline show and prove that we created. You can see that over on line 23. This is the source. The first step is checking out the source. You can see the commit message that we put in. You can also see the commit hash. So it is checking out the source code as we intended. Now the next part of the pipeline is the build. Remember we talked about the npm CI, right? That's the clean install command that is running. And then this is the CDK sent command that we told it to run over on line number 28. Now this part is the stage. This is what we created over on line 34 in the code. You can see that in the browser as well. This is what we created on line 34, the stage. Correlates to this part over here in the browser. Before anything happens, these unit tests have to run and they have to pass before you can continue. So you run clean install again, you run npm test. Let's look at the logs. Now down here you can see that it executed Jest. And look in the package JSON, you'll see how that works. And then here that our test succeeded. Now we can look at our Lambda. This is the Lambda that was created. We can go down here and test the Lambda. Invoke the function and see what it returns. Make sure it returns what we said it should return. And it will, because it's all in code. How can I move the crowd? First of all, ain't no mistakes allowed. So I think we can go back over to the code. Where is that? Inside of the Lambda. Yeah, services. Now, that's how that correlates. That's where this comes from. This is the Lambda function, so to speak, not the compute. This is a function. This is part of the body that's returned. So we're going to update that. And this is where the beauty of CI/CD is going to come in, because we're just going to push this to Git now. We're not going to do any more CDK deploy. We're going to push this to Git, and you're going to see magic, because the pipeline is going to fire. It's going to update our Lambda for us, all with no hands. No hands, no manual intervention, updated code in AWS, right from a commit. to GitHub. Let's see it. That is pushed. Go back over here to our pipeline and go back up to the top here. And we will go to review. Now you can see it's in progress. Now you can see we didn't do anything except push to GitHub. And then after GitHub receives it, fires off the pipeline, CI, CD, using the Amazon Web Services CDK and tools. So I hope you enjoyed this. Thank you so much.